First of all, we're looking at artificial intelligence. A birthplace of artificial intelligence can be thought of as computers. Computers are thought of in terms of binary one and zero. But back in 1950, a man that is thought of commonly as the grandfather or the father of computers, Alan Turing, posed the question, can machines think? And this is essentially what stemmed artificial intelligence, because this thought process that machines, computers that typically deal with ones and zeros, garbage in, garbage out, as I'm sure you've heard, might be able to think and process. So, what is artificial intelligence? Artificial intelligence is the theory and application of a computer's processing capabilities to complete tasks that usually require human intelligence. So artificial intelligence is probably one of the largest buzzwords in technology and society at large at this moment in time. With an advent in the Internet of Things, as Sam just spoke about, cloud computing, data, the internet, we are seeing more processing of more data than we've ever had before. We have connected devices, we have voice assistants, we have autonomous cars, and many more developments over the past decade. Companies worldwide are also tapping into the various opportunities that AI has to offer in terms of data mining and insights into consumer trends. In the field of artificial intelligence, there's a thought process. AI can be put on a spectrum that is from weak or general to strong AI, which is reasoning and learning. So if you remember at the start, I spoke about how artificial intelligence can be thought of as a computer using its processing power. So that's the chips, the electronic components that it has, and using that to complete tasks that require human intelligence. So thinking. So for example, when you see a color, you see the color, you identify the color, you process that the color is associated with something else that you know to be that color, and then you decide that that's the color. So this is much the way that we apply the human reasoning capabilities to computers or machines and systems. I'll take you through some of the examples of artificial intelligence that we have in the world today. If we start from the weak or general AI, so that's looking at things like vision perception, like I just mentioned. So the ability to verify and validate numbers. So we have things like license plate registration. A lot of cameras can decipher this is a number, or if you scan something and the software can decipher this is a number, or if you fill a form and it deciphers this is a number, this is text, and so on. That is vision perception, the ability to determine something from an image. And we have decision-making capabilities. So those are devices or software such as Amazon Echo Dot, Google Home, Google Maps. Like Sam mentioned previously, when you wanted to go from A to B, you had to do all the thinking along that route. So you had to get a map and plan it. If there was traffic, you were stuck in traffic. If the road had disappeared, the road had disappeared. You were on your own. But now we have computer systems such as Google Maps or Waze or Apple Maps that are connected via satellite GPS that are able to gather information from the real world, process that, and make decisions, and alter your route or inform you of traffic, inform you of a road blockage, inform you of different things, and alter the route. So able to make decisions based on information. And here I'll just like to talk about robotic process automation a little bit. So this is a field of artificial intelligence that looks at taking manual tasks and automating them. So things like sifting through data, sifting through calculations, repeatable tasks that a computer can then do and do so autonomously. So that's robotic process automation, and that's being leveraged by a lot of large organizations for their auditing, their accounting, and so on. There's a lot of benefits there because that frees up your workforce to do the tasks that really require thought and creativity. So you're removing the manual processes. And then we move into the stronger aspects of AI. We have language processing. So this is being able to take the words that are spoken, which is thought to be the more difficult parts, because we have nuance, we have context. But we have devices today such as Alexa, Siri, Cortana, Google Translate. They're able to take in inputs verbally. So that's the words that you speak, sentences, and so on. Gain insight, infer meaning, and give you a response or carry out a command. So that's language processing. Literally processing language can also be written, but processing that and carrying out an operation as a result. And then we have machine learning. This is where we start to get into strong AI. This is where we start to learn. So this is a key ability also if we look at human intelligence. Our ability to learn, retain, and apply information is something that we haven't always been able to translate to computers or machines. We have memory in computers, but to assign that memory to learn and then perform autonomously was not something that was previously possible. But now we're seeing, with the advent of increased computers, Sam said, better processors, better computers, we're able to feed computers with a lot more data and train them to help them learn. So we have facial recognition, fingerprint readers, and so on. And right at the forefront of strong AI, which is at the very edge, a fully autonomous computer or system, we have deep learning. So this is based on a machine learning technique to simulate the neural pathways in the brain. So I keep referring to the brain because if we look at artificial intelligence, we're trying to simulate human intelligence, and the center of that is the brain. If we think about deep learning, that's about imitating the neural pathways in the brain. Our brains have neural pathways which enable us to do things. And the way the neural pathways work is once you've done something once, it stores that electrical current. And the next time you do it, it becomes like a habit. And the more you do it, the stronger that pathway forms. And then we have deeper pathways in our brain. And deep learning is literally trying to replicate that to give us that ability in computers. So an application that we currently have is the IBM Watson fMRI machine, which is able to take input from millions of images of the brain and has been able to predict diseases and various things that doctors were not able to see from the images. And that was through repeatedly training it and using those neural pathways to do so. So that's an overview of artificial intelligence. I hope that's giving you a bit of an insight into what it is and the kind of sliding scale that we have. So what opportunities are available within AI? Like I said, there's opportunities for businesses, organizations of various sizes, from startups to multinational corporations. As Sam said, we live in a very connected world. That means a lot of data. If you look at it as an advertising agency, you're trying to sell things to people. You need to understand how people think. Consumer trends, there's a lot of information out there to process that, to get insight from it. You can use artificial intelligence, you can use machine learning to build models that will enable you to get insight from that at the click of a button. You don't have to sift through all that data yourself. And that can be applied to many industries, sports, healthcare, and so on. So there's also opportunities available for those who are interested in the industry. So there are various job roles and avenues that can be leveraged. So we have machine learning researchers. These are people who research and discover improvements to machine learning algorithms. So the foundation of artificial intelligence is algorithms. So an algorithm is simply a mathematical calculation that is performed. You put an input in and you get an output. And the machine learning algorithm essentially allows the computer to learn from the data that you input. So if you're trying to get output from an image, you would use an image processing algorithm, for example. Let's say you wanted to know the darkest spots in the image. You could write that and input it and run it against an image, and it will give you that without you having to manually search through it with a spectrometer or however else you'd want to do it. We also have data engineers, so that's around building the pipelines that transform that data. That simply means the infrastructure. So I've spoken a lot about data and research and data. You need to build the kind of system that will allow you to do that. And we have data analysts. If you love data, you can create and train systems to recognize patterns. And we have social scientists. So I spoke a lot about how we're trying to replicate the brain, but also along with the neural pathways and the recognition of pattern and the analysis, we also have nuances that we need to capture and we need to include in our artificial intelligence models. And that's where the social scientist aspect comes in. And we also have computer vision. So this is looking at automating human vision tasks via the use of image processing algorithms like I spoke about previously.